This is our study guide for Algebra 1, test number 1 from sections 1-1 through 1-2. First one's a multiple choice question. It says identify the fraction that's equivalent to 2 over 7. But what you need to do is you need to count by the number that it is. So for the top, you're going to count by 2s. That's probably the easiest way to do it. Counting by 2s, 2, 4, 6, 8. And for the bottom, when you count by whatever that number is, in this case, it happens to be 7. So 7, 14, 21, 28. Notice the fractions that we created from each of them, 4/14, 6/21, and then 8/28. The only one that pops up. And you can keep on going. You can count to 10, and you can count to 30, 32. You can count to 35, 10 and 35. But the one that we're going to actually use is 8 over 28. That's the only one that's available for you, A, for number 1. Number 2 says write the fraction in simplest form. Well, you want to find out the numbers that actually go into 18, or the same number that goes into both 18 and 30. The largest number that goes into 18 is 6. But let's say you didn't realize that 6 went into them. You said, well, they definitely both divisible by 2. If you divide by 2, you'll get this number 9 over 15 here. This is not quite the correct answer, though, because it could be simplified a little farther. Notice it says write it in simplest form. So as you look at 9 over 15, you notice the number 3 goes into both of them. So if you divide each of those numbers by 3, you'll finally get to the correct answer, which is 3 over 5. And there is no number that goes into both 3 and 5. Number 3 says write 3 times itself 6 times using an exponent. Count them up to make sure you don't make a mistake. 3 would be your base in this case, and that's what we have written here. 3 as the base and 6 as the exponent. So 3 to the 6th power. Number 4 says to write it in standard form. That says 5 to the 2nd power, or 5 squared. And when you simplify 5 squared, it means 5 times 5, or 5 times itself 2 times. And 5 times itself 2 times is 25. So if you're doing a multiple choice answer here, realize which one it asks you for. If it tells you standard form and it gives you this as a possible answer choice and this is not available, go with the first answer, 5 squared. 5 says we're adding these fractions, 5 over 12 plus 8 over 12. Notice for 5, your denominator is the same. That's a good thing. So keep your common denominator the same. Keep it 12, and then add 5 plus 3. 5 plus 8, you get 13 over 12. For number 6, do likewise. The same number 12 is at the bottom. Keep that common one. 6 minus 3 is 3 over 12. The difference between 5 and 6 with the answers is as you look at 5, there's no number that you can multiply by and get 13 that you can also multiply by and get 12. However, that is the case for 3 over 12. You can multiply by 3 to get 3. You can multiply it once. And by 3 to get 12, you can multiply it 4 times. And that's how we get 1/4. Number 7 and 8, 3/4 plus 5/10. The difference between these and 5 and 6 is their denominators are not the same. So the first thing you need to do is you need to create common denominators for number 7. The smallest number that 4 and 10 both go into is the number 20. If you use the larger number, you'll just have to simplify later on. But they go into 20. So what you need to do is you have to see, what do I have to multiply 4 by to get this number 20? Since you multiply 4 by the number 5, you also multiply the numerator by the same number 5. So 5 times 3 gives us the number 15. So 3/4 becomes 15 over 20. You ask yourself the same question on the other side. What do I have to multiply 10 by to get 20? And the answer is number 2. So multiply the top number by the same 2. So 5 times 2 gives you the number 10. So that's how we wound up with 10 over 20. Now we have common denominators 20. All you have to do is add 15 plus 10. But you'll notice that you get 25 over 20. That's not simplified because the number 5 goes into both of them. You can multiply 5 by the number 5 to get 25 and 5 by the number 4 to get 20. So you wind up with 5 over 4. For number 8, again, you don't have common denominators. The smallest number they both go into is the number 30. Ask yourself, what do I have to multiply 10 by to get 30? 3 comes to mind, so multiply 6 by the same 3. So 6 times 3 is 18. Do the same thing with this side. What do I multiply 3 by to get 30? 10. So multiply the 1 by the same 10. 1 times 10 is 10. So we have 18 over 30 minus 10 over 30. Keep that common denominator 30 and subtract 18 minus 10 to get 8 over 30. But it's not quite simplified because there's a number that goes into both of them, and it's the number 2. 2 times 4 gives you 8, and 2 times 15 gives you 30. So therefore, 4 over 5, there's no number that goes into both of those. Number 9 says 8 3/4 minus 4 1/4. There are two different ways you can do this. The easiest way for you to do it, however, is to take it as two separate problems. And what I mean by two separate problems, you can see, take the whole numbers out first. 8 minus 4, and that's what we have here, and that's why I circled it for us. 8 minus 4, we get the number 4. Then subtract the fractions. 3/4 minus 1/4. Good thing about it is 3/4 minus 1/4 have the same denominator. So keep the denominator common, 4, and subtract 3 minus 1 to get the number 2. So again, at this step here, we have 2 over 4. There's a number 2 that goes into both of them. 2 times 1 is 2, and 2 times 2 is 4. So now we have the fractions subtracted from each other, 1/2. So when we put 4 and 1/2 together, we get 4 1/2, and this is our finished answer for number 9. Number 10, you do not need common denominators for multiplication or division. You simply need to multiply straight across. 3 times 7 is 21, and 6 times 10 is 60. But there's a number that can go into both of these numbers, 21 and 60. It's the number 3. 3 times 7 is 21, and 3 times 20 is 60. There's no number that goes into both 7 and 20. Therefore, that's a simplified problem. Number 11 has division of fractions. It might be a little smaller on you guys' sheet to see. 5 over 12 divided by 2 over 8. You turn division into a multiplication problem. 5 over 12, change division to multiplication, and flip 2 over 8, or use its reciprocal. That's just a fancy way to say flip it, and then it becomes multiplication. Once you add this step, multiply straight across. 5 times 8 is 40. 12 times 2 is 24. Then notice that there's a number that goes into both of them. The number 8 is the largest number that goes into both. 8 times 5 is 40, and 8 times 3 is 24. Number 12 says write this as a decimal. 2 over 4 means 2 divided by 4. 2 divided by 4 is 0.5. Another way to do it is to see that 2 over 4 has the number 2 that goes into both of them. 2 times 1 is 2, and 2 times 2 is 4. So it reduces to 1/2, and we know that 1/2 is the equivalency of 0.5 written as a decimal. Number 13 and 14 ask you to write them as percent. Percent means per 100. So 63 per 100 means 63%, which gives you 63%. Another way to do it, just like we turn percentages into decimals by moving the decimal to the left, in order to turn a decimal into a percent, you move it 2 times to the right. So if you start with the decimal there, you move it once, twice to the right, you get the same 63%. Changing 1/5 into a percentage, 1 divided by 5 gives you the number 0.2. Again, just like the last one, once you have 0.2, move that decimal over 2 spots to the right to get 20%. Number 15, write 60% as a fraction or mixed number in simplest form. Again, percent means per 100. So 60 per 100% means 60 over 100. The first thing you can do it once you have 60 over 100 is you can cancel out a 0 from each of them. So now you're left with 6 over 10, a much smaller fraction to deal with. But there's a number that goes into both 6 and 10, because 6 and 10 is not a simplified answer. It's the number 2. 2 times 3 is 6, and 2 times 5 is 10. Therefore, 3 over 5 is your simplified answer. 16 and 17 ask you for the greatest common factor. When you're factoring out 16, this is how you factor out numbers. 24, if you multiply 1 times 24, you get 24. If you multiply 2 times 12, you get 24. If you multiply 3 times 8, you get 24. And if you multiply 4 times 6, you get 24. That's how you factor them out. You do the same thing with 54. Notice 1 and 54, 2 and 27, 3 and 18, and 6 and 9. The greatest common factor is what you're looking for. Greatest common factor. So the largest one that they have in common. The largest one they have in common, if you look at the first numbers, 1, 2, 3, 4, 6, 8, 12, and 14, the largest number that they both have is the number 6. Therefore, you list their greatest common factor as 6. 17 is a little bit tougher because you have, instead of just 2 of them, you have 3 numbers to look at. So as you're doing 3 numbers, here are your factors for 6. 1, 2, 3, and 6, because 1 times 6 and 2 times 3. 21 is 1, 3, 7, and 21. And 36, there are more. 1, 2, 3, 4, 6, 9, 12, 18, and 36. The greatest common one. Look at the first set, the one in 6. There's only 4 numbers there. Once it's not common among two of them, you can stop checking it. If you try to see if 6 is the largest one, right when you look at your factors for 21, there's nothing that you can multiply 6 by to get 21. 3, however, is common among all of them. 3, 3, and 3. Therefore, your greatest common factor for those three numbers is 3. 18 and 19 are almost the opposite of greatest common factor. Least common multiple. Multiples are easy for most people to understand. All you do is count by those numbers. 6, and then 6 more is 12, and then 6 more is 18, 24, 30. You can keep going on endlessly. You do the same thing with 10s. Those are easy for people to count by. 10, 20, 30. The least common one, so the smallest one you come to that they have in common. They both have 30 in common. It's the smallest one they have. Therefore, 30 is the least common factor. For number 19, this is actually a really difficult one. I didn't realize just how hard it was when I made the test. But what you want to do is you want to start with the largest number you can come up, the largest number, use those as multiples. All you do is count for each one. 16. Can I multiply 9 by something and get 16? No. 32. Can I multiply 9 by something and get 32? No. 48. 9 times something, 48? No. 64. And again, just counting by 16 each time. 9 times something to get 64? No. 80, 9 times something? No. 9 times something to get 96? No. 112. 9 times something? No. 128? No. 144. 9 times 9 times we get 16. In fact, it actually becomes 9 times 16, and that's another trick you can do. You could take two of the numbers you're looking at and just multiply them by each other, because you know it'll be a multiple of each of them if they're multiplying by each other. 144. So once you know 9 and 16 both go into 144, you can check to see if 4 does. And if you take 144 and you divide by 4, the number 4 goes into 14 3 times. Subtract 12 from it, you're left with 24, and 6 times 4 is 24. So 4 also goes into it. So our least common multiple, as tough of a problem as number 19 is 144. 20 and 21, we're finding perimeters. Of a triangle, perimeter is equal to A plus B plus C. Again, with addition, it doesn't matter the order that you put things in when you're adding them, but you add A plus B plus C. We'll call 25A, 18B, and 31C. 25 plus 18 is going to be 43, and 43 plus 31 is going to be 74. So our perimeter for our triangle, and it says they're all in centimeters, is 74 centimeters. For 21, they don't give us values for the ones that are not shown, but we know since this is a rectangle based on the fact that all 4 of them are right angles, this one has to be 15 feet as well, and this one has to be 10 feet as well. So once we know that, we could say, and here's the actual formula for the perimeter of a triangle: 2 times the length plus 2 times the width. And you can see if you just add it up, each of the sides, you'll get exactly what we have. 2 times 15 is the number 30. Plus 2 times 10 is the number 20. So your perimeter equals 30 plus 20. Your perimeter equals 50. Again, it's in feet, it tells us, for each of them. 50 feet. 22. Now we start in distance, rate, time problems. Says a car travels 497 miles in 8 hours. Find a unit rate. Here's that word, or that term, rate. We use it as R. We also think speed means the same thing. It says round to the nearest tenth if necessary. Our formula for finding a rate is equal to distance over time. So when you plug those values in, distance value is 497 miles, and your time value is 8 hours. 497 miles divided by 8 hours is 62.1, and again, it says round to the nearest tenth, 62.1 miles per hour. Notice about this one that miles divides by hours, but they don't cancel each other out, and that's why we have miles divided by hours, or miles per hour. 23 says a cyclist travels at a speed of 12 miles per hour for 2.5 hours. Find the distance the cyclist travels. So we're looking for D. Now we have 3 different forms of this formula. Rate equals distance over time. Time equals distance over rate. The other one is distance equals rate over time. It says find the distance, so we have to use that one. So distance equals rate over time. The rate is underlined in blue here, 12 miles per hour. And the time is underlined in green, 2.5 miles per hour. Notice it's hour is at the bottom of the fraction on the first one and at the top of the fraction if we wrote everything over 1 here on the second one. So they actually can cancel each other out, and it leaves us with just miles, which is an appropriate unit for distance. 12 miles times 2.5 is 30 miles as our distance.